Welcome back to Element 14 Presents. I'm Clem and I bought a huge big old sign. And the only thing I know, it has a power cord that looks pretty dodgy. So let's reverse engineer this thing and make it do my bidding. The power cord doesn't inspire much confidence. But anyway, I'm gonna plug this thing in and just take the risk and see if it even works. And turns out, oh, it does. And it has the old message from when it was last time used probably still on it. This came from an event company and I think I can guess the event where this was used, and you may also be able to guess it. I got the old rule wrong, I turned it on first, but now we're taking it apart and see what makes it tick. The screws don't inspire much confidence, but once I got it open, oh boy, there's a nasty surprise in there. Somebody used an AC-DC converter, which is not bad inherently, but they just soldered on the AC wires to the connector. This is like almost guaranteed to break at one point and almost guaranteed to short the case, not to ground, but to live or neutral, because there's not even a grounding wire in here and we have a metal case. This is so much of a safety no-go, we have to get rid of that completely. This thing even ripped apart when I just touched it to hook up my my current clamp, because I wanted to see how much power this actually could draw. But even like a little movement on the cables already made it snap. So this could have snapped at any point in its life, easily. So we're gonna rip that out. This is like, I've seen things like this in memes and very seldom in reality. And this is now like a live example of how bad it could be. Very interesting to me is that this thing seems to be a partial DIY jobby. So my suspicion is this: there was this case for the sign. Maybe this was already a sign, because the cutouts for all the plugs and stuff, they look professionally made and the board fits perfectly. They just added some screw holes to mount it. But what I think happened is that the original sign that was in there stopped working and they replaced the original board in there and the actual signage thing, like the thing where the LEDs are mounted. And they took that from a different sign with a different form factor, maybe, because the electronics would be able to hold a lot bigger sign, and there's clear evidence that the actual LED matrix, that was retrofitted to that. So this was cut up, resoldered, they doubled up on some traces, they soldered wires directly to the specific points to build up a new matrix. So I think somebody made a fitting matrix for this sign out of an existing sign of a different form factor. Seems to work quite well. I couldn't find much information on the original manufacturer. They may or may not be defunct. I think there's a company of that name still in business somewhere in India, but I'm not sure that's actually the same company. They might have just taken over the brand. They do different things now. Yeah, but looking at the board, this is now interesting. So we're having basically a DIY jobby, someone retrofitting this thing. The whole board runs on strictly 5 volts. This is great. That means we can make it a lot safer quite easily. Like a shining beacon of light, we can now run everything off 5 volts that come from the outside. So we're putting in a DC plug and powering everything just with DC from a proper, safe power supply. By coincidence, this is just a Raspberry Pi power supply. I had to retrofit the original connector, which was a USB micro. I changed that to a barrel plug, and the appropriate counterpiece will get mounted into the case in an existing hole that the original power cord went through. Well, it's not really the original power cord, but the one that it came with. Maybe this was the part where originally, like really originally, a power cord for a DC power supply would also have been fitted, or for an AC one. I don't really know. Any case, I'm not making any additional holes into this. I'm just making safe powering the thing a lot easier. And now it's time to investigate the board itself and see how it works. So to find out what this board actually does, measuring is my way of choice. So first, of course, I have to confirm that overall the board just runs on 5 volts and not some weird combination of +5, -5, +12, you know. Old systems might have weird voltages involved. If there's an op-amp in there somewhere, this is to be expected. But turns out this is an AT51 based system. Yes, that old microcontroller from the 80s that's still around and still everybody uses if they have to deal with legacy components. This is not something that I can just easily reprogram. I don't have a workflow for AT51. I don't know how to program them properly. This is before my time. What I can do is trying to find out how it takes in commands and then adapt my workflow to those commands. So I start by just poking around and seeing if I can make the thing change its behavior. And it turns out if I just stick in little leads on the connector that on first glance looks like a UART, an RS-232 connector, then if I poke around I can make it like inhibit, where it doesn't display anything and then it goes back to normal operation. But if I poke it rapidly, it seems that I can like clock in bogus data. So this might be an actual serial interface. And maybe we can just hook up to that and inject our own data so we can decide what to display. Breaking news, chaps! I found a keyboard and this piece of paper inside the other junk that this thing came in. And turns out the connector on there seems to be an actual PS2 connector, so for an older keyboard. And here's a little piece of paper that tells me how to get this thing to work with a keyboard. So the keyboard interface, well, that seems to work. If you press Shift F10 for a few times, then you can actually get access to not really a menu, but you can adapt the text. There has to be some sort of operational codes at the beginning and the end. This is listed on the sheet of paper. And then in between, that's your message that scrolls around alongside the board. This is, well, good for use at events, I guess, but I'd rather have a way to push serial data onto this thing. So before I'm gonna do anything more with that besides like make it display some messages to see if it still works correctly, I want to see if I can make this communicate with an Arduino. The Arduino of my choice is the Arduino Uno R4 Wi-Fi for 2 reasons. First, 5 volt logic levels, and second, Wi-Fi. I want to see if I can push data via Wi-Fi to this. This seems to be the easiest option for me now. If I would just use like a bare ESP32, then I would have to have some logic level conversion. Not gonna do that for this hack because this is a one-off thing, so I'm just choosing the easiest solution. So I better get my workflow going for that one. This time I'm programming it with Platform IO, but still I would say that the serial monitor of the Arduino IDE is still the better one that works more reliable. So yeah, time to prepare some code to see if I can actually communicate via UART with this connector on the outside. Well, so long story short, it doesn't react. Could be that the logic level is wrong. If I just try to pull pins low, then I get some behavior, but it's not consistent with the pins and stuff. And if I look closely at that pinout and correlate it to the parts inside, I'm not really sure this is a normal UART. This could also be some sort of internal interconnect between these boards, like if you have like multiples of these signs or multiple controller boards in one thing, and then you daisy chain them to make them into one bigger thing that displays the same message. I have a feeling that this is what this is actually meant for. It's just a theory, but it doesn't seem to accept any data, no matter if I just like push messages or if I try to send the exact same operation commands that the keyboard would send to make it tick. It doesn't seem. Maybe there is a special set of commands for UART that makes it accept new messages, but I don't have those codes, and I don't think there's a chance that I will find them out if they even exist. So I say we'll have to use our other way of controlling it with the keyboard, but still with an Arduino. Welcome to the Coding Void. This time it's all about how to emulate a PS2 keyboard with an Arduino. You will find plenty of libraries that emulate a USB port on an Arduino, so you can use a USB keyboard or a mouse with your Arduino, and the Arduino is the host. But we want it the other way around. So my first intuition was, is there a library that I can just use? I didn't find one at first glance, so I tried to do it from scratch, because it couldn't be that hard to emulate the keyboard, right? These are pretty simple devices. Turns out some vibe code isn't gonna do it. I tried with the help of the like AI coding agent thing that is in VS Code. That didn't work out well. But then I found a hint on a forum, and it says there's a library called PS2 Dev. And that one popped up earlier in my feed, and I thought it was the other way around. It was a library for hosting. But it isn't. It's a library that can simulate keyboards and mice. And with that library, I was able to get the correct signals on some pins. Yeah. Turns out the standard pins that the library wants to use, 3 and 2, these are not the ones that work best for the job on an Uno R4. They would have been on the old Uno. I used pin 10 and 11 for that. These worked fine. Confirmed everything with my oscilloscope to see if they properly go high and low. Finally, some success. I struggled really to make that output the right bits with the coding from scratch bit. Don't try that, use a library if you can and you have the space on your microcontroller. And then it's about sending the right commands to the LED sign to make it enter the menu and let me change things. So at first it wouldn't react at all. I tried connecting my Arduino with the connector, like a proper PS2 connector that I cut off from an older device and soldered to the wires, and it wouldn't react at all. And I don't know why. The pinout is right, I think. And I confirmed that multiple times, but it wouldn't do. But when I soldered directly to the underside of the board to the actual pins on there, now it works. But it doesn't really take in all the commands. So what I had to do was delays. This thing is an 8051 running at, I don't know, 1 megahertz max. Probably less. I didn't really check the crystal. But the thing is, this expects human delays or human speeds of entering data. So what I have to do is for each key press and release, I had to give it enough time for it to actually react to each keystroke and to like show up on screen. Then I tuned that down until it stopped working, and then gave it a bit more delay again. So basically I gave it low typing and then sped it up and then slowed it down again, so it would just be long enough for it to react. Turns out 50 milliseconds for each key press and release is enough. And to make it automatically remove the old message completely and give me a new one, I just made it type 50 times delete, 50 times backspace, then everything is clear, and then you can enter the full new message. This was quite the trial and error journey to make that work reliably, because it's just trying out what works. If you're emulating human things, you have to put in a lot more margin of error than if you're emulating machine things. The people accused me of being an AI hater or being too pro. I'm neither. I think you should take advantage of it where it makes sense. And where it makes sense is coding repetitive functions, for example, that you need over and over again. So what I now want is an interface that allows me to input whatever I want to display on the board. Just that one, not the full command, just the message. In the serial terminal, it processes that and then it submits the right keystrokes to make that happen to the LED sign. And that is basically written by an AI thing. So that needed a bit of tweaking. You have to be prepared to look through the code and see the errors and then correct them, do trial and error. You may take longer for that than writing it yourself, so be aware of that. But that worked quite good. And now I could basically push stuff over serial directly to the board, the LED board or LED sign board. How do you call that? It's a signage board? I don't know. Anyway, this is not the last thing I wanted to try. I said I want to have this thing connected, like network. So I could now, every time I want to change the message, take out a USB cable, go to the sign, plug it in, give you the new message with a laptop, restart it. Oh yeah, you have to restart the sign every time you change the message. This is, yeah, if you reset the board with the reset pin inside, doesn't change. I think it needs a full power cycle. Well, I don't think all the things are resetting at the same time. This is just the processor reset. So that basically just makes garbage on the display. So you have to actually power cycle it. Not a very nice solution. You could potentially automate that with an Arduino as well, with a little relay. Maybe I do that later. But now I want to have this thing connected, so I don't even have to walk to it. I want this to work over Wi-Fi. So a lot of vibe coding later, or basically AI assisted me trying to figure things out, because I haven't worked with an Arduino R4 and its Wi-Fi capabilities before. Turns out if you ask AI to do it, they will just use the Wi-Fi library like on an ESP32, which is wrong. You need the Wi-Fi S3 library, as it says in the Arduino Uno R4 tutorials. So listen to the tutorial. What I found is that letting it connect to my home network wasn't very reliable. There might be some quirks in that library, I don't know. But sometimes it would connect perfectly, sometimes it won't. Or it tells me it is connected but doesn't get the right IP address. So this isn't the way I wanted to use it anyway, so I'm using the access point mode, which worked a lot better. I can just set credentials and then access it over my phone. Turns out this also isn't the most reliable one. I think there might be some coding issue with my code or with the library. I don't know, I can't judge. But at least I got this to work good enough for a little demonstration, and maybe you know how to do it better. So check out the code on the Element 14 community page and tell me what I did wrong. This would help greatly. Anyway, I was able to make this push code onto there with an endpoint. So if you enter the IP address, which I fixed, this is 192.168.2.2, doesn't matter, it's like a local IP. You can choose a different one if you want to. LED sign / whatever you want to display on there. Trouble with that is, if I have a space in there, it doesn't work anymore. So what I wanted to do next is not fix that. I let the computer do the fixing. I want to have a little HTML page that just comes up. You enter whatever you want to display and click on send, and then the display should update and I just have to power cycle it. So this is what I did. Very easy page. Thank you. I think ChatGPT Mini is now the thing that's included in VS Code. Anyway, this worked quite good. We now have an interface via Wi-Fi and via serial. There's just one thing left to do, and that is plug it in and enjoy its glory. If you want to have all the resources that are used in this build and all the code and stuff, you can download that on the Element 14 community. You can go there to connect with me and all the other hosts, and I would love if you would tell me your project ideas for stuff that we should build on the show. So, one thing... I gotta go. There's another project waiting for me.